In this video session, we are going to see overall concept overview of real numbers for the 10th standard CBSE Mathematics. First of all, let us see the mind map of the real numbers. Gives you the overall picture of what about real numbers, all about real numbers. All you need to know about the real numbers. So first of all, real numbers are broadly classified as rational numbers and irrational numbers. We see irrational numbers, rational numbers. Rational numbers can be expressed in the form of P by Q, in the fractional form, P by Q, where P and Q are integers belonging to Z. Here we mention that capital Z is a letter, denotes the set of all the integers. And here P is not equal to 0. We have a set of integers. Under rational numbers, we have a number of subsets. We have integers. Integers are denoted by a set of integers denoted by the capital letter Z, Z. The whole numbers which include only the positive, that is 0 onwards, 0, 1, 2, 3, up to infinity, that is called whole numbers. And it is denoted by the capital letter W, a set of all whole numbers, 0 to infinity. Natural numbers are the counting numbers. They are denoted by the letter N, the capital letter N. It denotes the set of all the natural numbers starting from 1, 1, 2, 3, 4, etc. We have the properties of real numbers. Every composite number can be uniquely factorized as a product of the prime numbers. This is known as the fundamental theorem of arithmetic, actually. The fundamental theorem of arithmetic, apart from the order in which the prime factors occur. Every composite number can be uniquely factorized as a product of prime numbers, except for the order in which the prime factors occur. We also have the Euclid's division lemma, or the algorithm. A is equal to Euclid's division algorithm. We have dividend is equal to divisor into quotient plus remainder. We have irrational numbers on the other side. That is, irrational numbers are those denoted by capital I. Rational numbers are denoted by Q. A set of all rational numbers as capital Q. Set of all irrational numbers as capital I. Especially, these are not expressible in the form of P by Q. P and Q are not integers in this case. So, they are non-terminating decimal expansion. They are non-terminating as well as non-repeating decimals, non-recurring or non-repeating decimals. Example, we have square roots of prime numbers. All the square roots of all prime numbers are irrational. And also pi, and a special thing called E, the small letter E, the exponential function, is also exponential is also known as, is also coming under irrational numbers. We also see in this topic, real numbers, we see the HCF and LCM using Euclidean algorithm as well as prime factors. We have a formula here. HCF and LCM is equal to the product of numbers valid for two numbers only. HCF of two numbers is into the LCM of the two numbers is equal to the product of the two numbers. Decimal expansions, there are three types of decimal expansions for real numbers. First of all, terminating decimals. Denominator has only 2 or 5 as prime factors. Non-terminating, repeating. Rational numbers with denominators having other than 2 and 5. The denominators other than 2 and 5, if they have factors other than 2 and 5, then the decimal expansion is non-terminating and repeating. A digit may or two may repeat indefinitely. Whereas non-terminating and non-repeating decimal expansions for irrational numbers, only for irrational, they represent irrational numbers. Now let us dive into the actual topic. The topics here are organized such that real numbers denoted by capital R in general. Capital letter R includes all rational and irrational numbers, a set of all rational and irrational numbers. Rational numbers denoted by Q, capital letter Q, can be expressed as in the form of P by Q, where P and Q belong to Z. This capital letter Z, as you know, it is already defined as the set of all integers, Z, when Q is not equal to 0, the P by Q form. It includes integers Z, Z, whole numbers W, and natural numbers N. So these are all coming under subsets of the rational number. It also includes integers, whole numbers, and natural numbers, apart from the other decimal terminating and non-terminating recurring decimal, repeating decimals expansions. Next, we move on to irrational numbers, non-terminating, non-repeating decimals. Square root of 2, square root 3, root 2, root 3, root 5, root 7, etc. All the square roots of prime numbers are irrational. And the letter pi. The quantity pi is often used for calculations for surface areas and of circles related to circles. So when we come across, and also some surface areas and volumes. When we come across this pi, we can take it as 22 by 7, but it is not correct. It is not the exact, it's not a rational number, because 22 by 7 is in the P by Q form, but it is an approximate, it's an approximation. It can be expanded as 3.14159 and so on. It goes indefinitely. And also it doesn't repeat in a proper pattern. It will go on randomly that is called non-repeating. That is called. E is another 2.71 and something like that. It goes on like that. It is a exponential, it's called. It's also the base of a natural logarithm. Now coming to properties of real numbers, closure property, as you already studied in the lower classes. These are learned in the lower classes itself. Our real number is closed under subtraction, addition, subtraction, and multiplication, because if you do addition, subtraction, and multiplication of two real numbers, you will get a real number itself as a result. That is called closure property. Whereas division is not closed. Division of real numbers is not closed, because when you divide real number by another real number, you are likely to get an irrational number. You are most likely to get a irrational number, not a real thing. So, and we will be getting this particular thing, multiplication. So, closure property. Commutative property is interchanging the operands. It will be the same. Associative property is again grouping. It's just grouping of the two variables. Or just we find that it can be grouped anyway. A plus B can be grouped, or B plus C can be grouped. Distributive property is distributive over addition or subtraction, distributing A into B plus A into C over addition. It can also be done over subtraction. Distribution of multiplication over addition or subtraction. This is a very important property. These properties are hold good for even for integers and other numbers. Identity elements. Additive identity is 0 because when you add 0 to any real number, you will get the same number. That is why it's called additive identity. Multiplicative identity is 1 because when you multiply any real number by 1, you will get the real number itself. So it says it's the same. So that is why it's called multiplicative identity. Inverse elements are those additive inverse, negative a, minus a, negative sign. Negative a is the additive inverse of a, because when you add the negative a and the positive a, you will get 0. That is why it is called additive inverse. That is why it's called additive inverse. Multiplicative inverse, on the other hand, is the reciprocal. The multiplicative inverse of a is 1 by a, because when you multiply a and 1 by a, it's reciprocal, you will get 1. Here a is not equal to 0. That is the only condition. So when we multiply 1 by a and a, we get 1. Then it is called multiplicative inverse. So we can say that multiplicative inverse is also known as the reciprocal. Now, coming to the fundamental theorem of arithmetic. Every composite number can be uniquely factorized as a product of prime numbers apart from the order in which the prime factors occur. Example, we have 6, for example. 6 is equal to 2 into 3. It can either be written as 2 into 3 or 3 into 2. Doesn't matter. But it will have only 2 and 3 as its factors. There are no other factors. Like that, any number, any composite number for that matter, can be factorized uniquely. The prime factorization of any composite number is unique. That is the meaning of this. Now coming to the Euclid's division lemma or Euclid's division algorithm. Algorithm means it will repeat itself. Here, lemma is just a statement. It just gives you a statement that any two integers, a and b is not equal to 0. We have a is equal to bq plus r. What is this a and b? A is the dividend. B is the divisor. Q is the quotient. And r is the remainder. And the remainder is always less than the divisor. That we can easily see by actual long division and other things. We are using this lemma only. Now coming to the HCF and LCM using the Euclidean algorithm or you can also do by the prime factorization method. In the 10th standard CBSE syllabus, only prime factorization is included. So it's available. So we will just, we already know, we have also solved a few problems based on this. So, just by repeated division using the prime factors. HCF, highest common factor. It's also known as GCF, GCD. We also given as GCD or GCF, greatest common factor or divisor. Here, the greatest divisor common to 2 or more numbers. Then we have LCM, least common multiple, smallest multiple common to 2 or more numbers that can be divisible by a number that is divisible by 2 or more numbers and should be the smallest. We have this formula, HCF into LCM is equal to product of numbers for 2 numbers. Hence, we can say HCF of A comma B into LCM of A comma B is equal to A into B, where A and B are 2 real numbers. You can also use real numbers, but here we are using integers and whole numbers. These are some of the important concepts one more concept is there. Decimal expansions. The decimal expansions of real numbers are of three types. Terminating decimals. Denominator has only 2 or 5 as prime factors. Example, 3 by 10. 3 by 10. 10 is either it's just 2 into 5. 3 by 8, for example. 3 by 8 means it has 2. 2 cubed. 2 into 2 into 2. So you find either 2 or 5 or both as its denominator as the prime factors. So then it is a terminating decimal expansion. Rational number. Rational numbers are also non-terminating repeating decimals or recurring decimals. Rational numbers with denominators having factors other than 2 and 5. For example, 1 by 3, 2 by 3, 1 by 7. These are block repeating. That's called one or more digits may be repeating in the decimal expansion. It goes on indefinitely. Non-terminating, non-repeating decimals represent irrational numbers. Irrational numbers, they don't follow a fixed pattern on in their decimal expansion. For example, pi, 3.1415, again 1 comes, but changes to 5. It doesn't repeat, it never repeats again. Again, it becomes 5, then 9, and then it goes on. It goes indefinitely. It will not terminate at all, infinitely. And we can, for our approximations, we can take it as 3.14 for calculations. Simplify our calculations. We say pi is equal, take pi equal to 3.14. That's all. In just 2 decimal places. Because it goes on like that. And this type of decimal expansion is there. So coming to the overview of this concept of all these things together, we have an overview of the entire real numbers put together. We are just imagining a diagram here. Look at this diagram, you will find out rational numbers and irrational numbers. Rational numbers, you can see a Venn diagram. This is called a Venn diagram or set diagram. And we find that integers are inside this rational numbers. Real numbers consist of rational numbers and irrational numbers. Only 2 broad classification. Just have a broad types of real numbers. Rational numbers, we have under real numbers, we have rational numbers, inside which we have integers. Integers are also rational numbers because they can also be expressed as P by Q form. 3 can be represented as 3 by 1. Positive and negative values are possible. Whole numbers are only positive values. They start from 0, 0, 1, 2, 3, 4, etc. Natural numbers are counting numbers 1, 2, 3, 4, etc. up to infinity. On the other side, we have irrational numbers. Pi, root 10, root 2, root 3, and 1.24 and so on. 243, 487, 185678, like that it goes on. There is one more, root 2 is example. We just take an example. Root 2 is 1.414. One something else. Root 3 is 1.732. 1.732. And so on. It goes on repeating itself. And this is all about the real numbers. And we go back to the concept map, the mind map. And this is all about, all you need to know about real numbers.